Hello, I trust you're having a great day. Remember, we're supposed to have had a live YouTube session yesterday to touch some topics, but we're not able to host it because of certain technical problems that I couldn't take care of. Okay, so I'm going to teach you right now in replacement of what we're supposed to have done yesterday. So if you're ready to learn, join me in today's immersive learning. So I'm going to start with mathematics. We're going to touch on certain topics in mathematics and solve some questions extracted from our mathematics practice test and mock examination course, which we launched on Udemy recently. So if you are yet to enroll in the course, it's on Udemy. I'm going to include the link to the course in the description. I will also place it in the comment section. So you can click on the link now if you are here to enroll or later after the class because it's very good if you can enroll and then be following up because most of the questions, about 99% of them will be extracted from the uh, practice test and mock exam course, which we launched on Udemy. So I'm going to take you on some questions, okay, on some problems and certain topics. I want to start this class with indices because it's a very fundamental aspect of mathematics that a lot of people overlook. Indices is a key point in mathematics. By looking at maths. Okay. So what is indices? Okay, simple English language will let you know that indices means powers, but the root of this word is index, which is power. So whenever you hear indices, remember it's all about powers. Powers. It's just like standing and carrying something on your head. You are the base value, and then what you are carrying on what is on your head is the index. So let's say we have a number like this 10 power 2, 10 raised to power 2. Okay, this is something you have seen a lot of times, or you have 2 power 3, or 4 power 3, or 3 power 3. Okay, so all the values placed at the top, they are all index, or powers. Okay, so index is the singular of indices. Index singular, indices plural, power singular, powers plural. So when you write a number and then you place another value on top of it, the main value is the base value, okay, and then the power is the index. So when you raise a value to a power. The power is the index. If there are many, if there are more than one, they are called indices. So indices is the mathematics of powers. That's what it's all about. Mathematics of powers. And one thing I love about indices is that it simplifies mathematical expressions. Take for example, you want to write 1 million, okay? But you feel like this is too much for you and then it is too long, it's going to take so much space. You can simply write 10 raised to power 6. How? By counting 1, 2, 3, 4, 5, 6. You get there. So you say 1 times 10 raised to power 6. It's still the same thing. That is, if you are told to convert this to a standard form, this is what you get. You can quickly raise this, you can quickly raise 10 to power 6 to have your 1 million. So you can see that this expression has simplified this value. So instead of writing 1000, you just write 10 raised to power 6 and you have your 1 million. Okay, so indices makes mathematics simple. It compresses a lengthy expression. Okay, so it's one thing I love about it. So indices is just the mathematics of powers. The mathematics of powers. And indices as a topic in mathematics is connected to standard form. When you're asked to put something in a standard form, okay, and then indices, like both of them are related. Let's look at the 0.0032. To put this in a standard form, you have 1, 2, 3. That is 3.2 times 10 raised to the power minus 1, 2, 3, minus 3. So the index is this minus 3 or 3. Okay, that is the power. But this is the standard form of this. Okay, good. So it's having minus, of course. I'm sure you are aware that it's having minus because the value is less than 0 or 1. Okay, any value that is less than 1, the power is always minus something. In this case, it's minus 3 because you started counting from here 1, 2, 3. Okay, you stop here. Okay, that's great. So let's quickly go straight to the point and treat what we have come today to learn. Um, if you have already enrolled in the mathematics practice test slash mock exam course we launched on Udemy recently, I want you to go to practice test two. Remember, there are six practice tests: one, two, three, four, five, six. So go to practice test two. When you open it, you can either use the practice mode or the exam mode. You go to exponents, logarithms, radicals, and sets. That's where I'm extracting these questions from. That's where you see indices. Okay, that topic indices is under exponents, logarithms, radicals, and sets. Okay, and I want to start with question one. Question one. Now, let me mention before we proceed, there are more than there are more than six laws of indices, okay? But for the sake of this question one, I'm going to give you uh, just one of them, okay? No, two. I'll give you two of them, okay? The addition law and the subtraction slash division law. So in indices, laws of indices, let's take this one. If you have a power 2, a power n times a power m times a power p, it will give you equals a power n plus, sorry, I'll have to write it in a way that you'll be able to see very well. So you have a power n plus m plus p. Okay? So this law, this addition law, states that when in a multiplication case, now let me put it in a sentence. In a in a multiplication case, okay, when the bases are the same, add the powers, add the indices. As you can see here, a power n times a power m times a power p. The bases a, they are the same, but the powers are not, the indices are not. So you add the powers. You pick just one base, which is a, and then you add the powers. The powers are n plus m plus p. That's one of the laws. In fact, that should be the first one. In a multiplication scenario, when the bases are the same, add the powers. Okay? And then number two, the second law, which is related to this particular question one, extracted from the practice test that we're looking at now. The second law, which you need to know about, is if you have a power 4 divided by, a power m divided by a power n, it should give you a power m minus n. So in a division case or division scenario, when the bases are the same, subtract the powers. Subtract the powers according to the order of arrangement. As you can see here, a power m divided by a power n. The bases are the same, a and a, but the powers are not, the indices are not. So you collect one base, which is a, then you subtract the powers. You subtract n from m. Okay? You can put this like this: a power m over a power n equals a power m minus n. It's the same thing. So those two laws that are essential to this question one that I'm about to solve with you now. So question one, you can see this particular question when you go to the mathematics practice test slash mock exam course we launched on Udemy. That is just the question one under practice test two. This question is extracted from indices as a topic. Now, see how it goes. Question one. Question one under practice test two, under the domain of exponents, logarithms, radicals, and sets. So question one says, if you cannot find this particular question, please comment in the comment section. Let me know. If you have any challenge in navigating the course, let me know. Any question about the laws, let me know. Any concern you may have regarding the questions I'm solving, please let me know. Okay, so question one says evaluate. I will just write it the way it's written in the course. 2 power 3 times 2 power 4, close bracket, divided by 2 power 5. I'm not going to wipe away the laws because we'll be looking at them while we are solving this. So evaluate, bracket open, 2 power 3. This is 3. 2 power 3 times 2 power 4, close bracket, divided by 2 power 5. Now, we are going to use those two laws. That's actually why I wrote just those two, because we'll be using them. We'll use this one to fix what is inside the bracket, and then we use this second law to fix this. All right? So, let's get started. I'm going to clean this so that we have enough space, but I will place the question at the top. All right, let me rewrite the question. 2 power 3 times 2 power 4, close, divided by 2 power 5. Good. So solution. Okay. Now, let's say you are solving for WAEC. Remember, if you are solving questions in WAEC and NECO, especially theory questions, if it's objectives, you can maneuver, you can take the shortcuts, you can even use your brain and do the calculations and pick the correct option from correct answer from the options given to you. But if you are solving theory questions, you need to show working. Please do not forget there is no shortcut in solving theory questions in WAEC and NECO. JAMB is objective, so you just see the options and you pick the one that you think is correct. But for WAEC and NECO, you need to solve and show working, show all the steps. In fact, the steps carry more marks than the final answer. You may miss the final answer, but if your steps are correct, I can tell you that you may likely get 80 get 80% out of 100. Okay, if all your steps are correct and just the final answer is wrong. So steps matter a lot. So if you are solving for in WAEC and NECO, you have to follow the steps. But if it's jump and maybe for personal practice, you can just cut time short. But I just want to take time to teach you everything you need to know about this. So the first thing you will do is always good to repeat the question. It's very important so that the marker or the teacher will know that you're actually following. So we can actually repeat what we have been given. You can say given to evaluate 2 power 3 times 2 power 4, close, divided by 2 power 5. You can now say, according to the law of indices, according to the laws of indices. Now I'm trying to be explanatory in my teaching. According to the laws of indices, a power m times a power n times a power p equals a power m plus n plus p. Good. You have established a background, okay? Now, you can also move over to the next law, which says a power m divided by a power n. It will give you a power m minus n. So you have established some concepts. Whoever is going through your solution will know that you actually understand this topic very well. You see, that's why I like to understand whatever I'm learning. I try to get it, like get everything I need to know about it. You dig deep and learn from the roots, from the ground up, so that you make sure that you have at least 99% proficiency and knowledge in that particular aspect. So that when you are solving problems, you can be able to give examples, draw diagrams, enumerate, elaborate, uh, put your answers in tables, give examples, expand your solution so that whoever is reviewing your work will know that you actually get the topic, that you will understand it very well. So, having established this, you can now proceed to solve. Okay, you can number the laws. Maybe you say law 1, law 2. Okay, from law 1, 2 power 3 times 2 power 4 is the same as 2 power 3 plus 4. Don't forget the laws. If the bases are the same, add the indices, which is 2 power 3 plus 4 is 7. 2 power 7. You have solved what is inside the bracket. Now let's solve the one that is outside, which is okay. Now that we are done with this, we can now write it as 2 power 7 divided by 2 power 5. Okay? And that's what this law is all about, as we have established. So, having done this, we now apply them to this. From law 2, okay? Law 2. A power m divided by a power n equals a power m minus n. Concept established. Now you apply it into the problem, which is the bases are the same. So therefore, 2 power 7 divided by 2 power 5 equals 2 power 7 over 2 power 5, which will give you 2 power 7 minus 5. Okay, so you collect the powers, this index, both of them indices. Collect the indices and subtract them. They have common bases 2 and 2. Then the subtraction should exist only between the powers, which are 7 and 5. Okay? And don't mistakenly put it this way, 2 power 5 minus 7. That's wrong. Remember, 7 comes before 5. So you follow that order. That is 2 power 7 minus 5, which gives us 2 power 7 minus 5 is what? 2. And that's the final answer. Okay? That's the final answer. All right. So it's pretty easy to solve this problem. Okay? It's not difficult. It's very easy. So simple and really interesting and quite engaging. All you need to know is first understand the laws. Know that there are laws of indices. A lot of students in secondary school don't know about indices. Okay? If you don't know what indices entails, it will be hard for you to solve a problem like this. And the thing here is that in exams, you are not going to be asked to solve it in a linear form. I know quite all right that you can simply say 2 raised to power 3 is 2 times 2, 4 times 2, 8 times 2 raised to power 4, 2 times 2, 4 times 2, 8 times 2, 16. Okay, divided by 2 power 5. Okay, which is 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So you can have 8 times 16. 8 times 16, you can break it down to 8 times 3, which is 24 times 2, which is 48. 8 carry 4. 8 times 1, 8 plus 4, 12, 128. And then 2 power 5 is 32. So you have 128 divided by 32. Okay? So this is just the linear form. But in your exams, you're expected, if you are to show working, you should follow the laws of indices. Don't solve it like this in your exam. So you have 128 over 32. Okay, let's break it down. Let's start dividing using 2. You have 16. right? If 2 divide this, what do we have? 64. Yeah, 2 divide 100, 50. 2 divide uh, 28, 14. So 64. 2 again, you have 8. 2 again, 2 here, you have 32. 2, 4, 2, you have 16, right? 2, you have 2, 2, you have 8, 2, you have 1, 2, you have 4. So you have 4 over 1. And 4 over 1 is the same thing with 2 power 2. 4 over 1 equals 4. And 2 power 2 equals 4. Okay, that is 2 times 2, 4. All right? So this is really, really simple. Really simple. If I wiped anything before you copied it, you can just pause the video and copy before you go on. Okay? All right. So let me recap. You were asked to evaluate 2 power 3 times 2 power 4 divided by 2 power 5. That's what you were asked to evaluate. So we followed the laws of two, we used 2 laws of indices applicable in this question, which are the addition law and the subtraction slash division law. So when you are given something like this in which the bases are the same but the powers are not, pick one base and sum the powers. Then if you are given something like this where the bases are the same, in a division case, if the bases are the same, subtract the powers. First, we picked 2 and then added 3 plus 4. And what we got was 2 power 7. And then we now apply the second law, which says 2 power 7 over 2 power 5. If you have something like this, bring out 2, 1, 2, and then subtract 5 from 7, which will give us 2 power 2, which is 4. Okay? So remember the second approach I used, the linear form of solving it. That's not what you're asked to do. Okay? I just showed you another way you can solve it. But if you are given something like this in exam, follow this step, okay? Step by step. You need to show working. All right? You need to show working. So the final answer is 2 power 2. So check if you have not started the practice test, the mathematics practice test, if you have enrolled and you're yet to begin taking the course. You can jump all the other questions and move over to practice test 2, question 1, under exponents, logarithms, radicals, and set. And this particular question has been extracted from indices. Indices is a simple, interesting, amazing, and let me say sweet topic in mathematics because it's not just among the fundamental aspect of mathematics. It's one of the ways of compressing lengthy values, one of the ways of simplifying lengthy expressions, mathematical numbers and values. Okay, so join me in my upcoming videos. I'm going to make more videos on indices. Okay, the next few questions will be solving in mathematics will be extracted from indices. Okay, when we are done with indices, we move over to another topic. We also have lessons, have classes in other subjects, not just mathematics, across all the secondary school subjects. So whatever subject combination you are taking, okay, you are welcome to join us. Whether you are in arts or science, we're still going to treat some arts topics, okay? Literature, government, CRS, English, economics, geography, computer, physics, chemistry, biology. We will be treating all of them from time to time. But why I'm starting with mathematics is because is a fundamental subject, is an essential compulsory subject. Maths and English, mathematics and English, they are so important and essential. Not that there are more, not really that there are that you can throw the other subjects away. No, every subject matters, okay, because they are unique in their own way. But why we express so much interest and attention on mathematics and English is because without them, one, you won't gain admission, okay, and then they are usually the most difficult. People find mathematical questions difficult to solve. In fact, a lot of students get tired, they give up without even trying. When they hear maths, they start shivering. That's not good. Mathematics is an interesting subject because math is life, mathematics is life. I don't really want to go deep into the philosophy of mathematics and what I believe about it. But all I need to tell you now at this moment is that mathematics is an interesting subject. It's not hard. It may be challenging, but it's not impossible to conquer. So if you want to learn and advance in your knowledge, if you want to progress in your academic endeavor, join me in my lessons. Watch this video to the end, solve exercises, enroll in the practice test that we have launched on Udemy. Pick your subjects, all the subjects you offer in secondary school. If there is any one that you need but we have not launched it, let me know in the comments